On this slide, you see some different shortcuts and things, and it's shortcuts that's really going to help us out, especially if the n number on top of the sigma symbol is pretty large, okay? So a couple of things to point out. That C right there is just a constant number, like if that's 50 or 12 or whatever. So that constant, that's just a number. And down here, these are really useful. Your variable, variable squared, variable cubed. Look for those because you can do a substitution and use one of these shortcuts. All right. So 6a, use the summation properties to find each sum. Okay. So really what this is saying is the sum of 12 50 times, okay? If you sum this out, if I equals 1, you've got 12. If I equals 2, you've got 12. If I equals 3, you've got 12. All the way up to 48, 49, 50, you're going to have 50 12s. And so that's exactly what this shortcut says, all right? You've got this number in 50 times 12. Because if you added them up, it would be 12 plus 12 plus 12 plus 12, 50 times, all right? 50 times 12 is 600, that's it. All right, so then the next one, all right, you've got the sum from I equals 1 to 35 of 3I. Looks like, well, it kind of looks like this one, where I can pull that constant number out in the front. So I would start by pulling that 3 out in the front. And I would change this to 3 sigma I equals 1 of I. Okay? But now what you've got is you've got this one. Okay? You've got sigma I, which turns into this part of the shortcut over there. N times n plus 1 over 2. So I don't really have to do all the adding, and I don't have to add up from 1 to 35, basically, because I can just use that shortcut. So I'm going to have the 3 in the front, but then I'm going to have my shortcut n times n plus 1 over 2. All right. Now n is just this number on the top here. That's n. So we are looking at 3 times 35 times 35 plus 1 over 2. So get your calculator out and plug that in. 3 times 35 times 36 over 2 is 1890. That's the sum. Okay, so then the next one. I would do this in a couple of parts. If you imagine, take out the parentheses, you're going to have a 3 come out in front of the sigma with an I behind it. Plus you're going to have a sigma with a 5 behind it. I used a couple of those shortcuts, okay? Just like when I did this one, I pulled the 3 out in the front, all right? So I'm going to have a 3. Oh, wait, I forgot the squared right there, right? I'm going to have a 3 with the I squared shortcut. So go back and look at the I squared shortcut. The I squared shortcut is a little bit more complicated. It's this one, right? So I'm going to have 3 times, what is that? Let me back up here. N times n plus 1 times 2n plus 1 all over 6 plus, and then remember when we have a sigma times a constant, it was this one. So it's going to be n times c. In this case, there were 10 of them. That was n, okay? But it's going to be n times 5. Okay, 10 is n, so I can plug that in. 3 times 10 times 10 plus 1 times 2 times 10 plus 1 all over 6 plus 10 times 5. Okay, you can clean all that up. All that stuff's going to equal 1155 plus 50 over here, 1205. Example 7 is the same kind of deal, but I've got to split it up a couple of ways. All right, I'm going to have a sigma I cubed plus, I've got that constant 2 in the front, sigma I minus a sigma 8. Okay, so I cubed, go back and look at I cubed's shortcut. I cubed is this one. All right, so that's going to be n squared times n plus 1 squared over 4. Is that right? Okay. And then plus, you're going to have a 2, and then the I shortcut, we've already used the I shortcut once, was 2, or n times n plus 1 over 2, minus, and then the constant number is just going to be n times 8. All right, so we plug in our n number. The n number was this, 5. So we plug that in, and you're going to have 5 squared times 5 plus 1 squared over 4 plus 2 times 5 plus 1 over 2 minus 5 times 8. So a lot of arithmetic going on here. So once we clean up this part, this is going to equal 225, and all of this is going to multiply and clean up to 30 minus 40. That's altogether going to be 215.